You're probably expecting to encounter a lot of new terms and concepts throughout this video series, and you are correct on that. In the last video, I mentioned the data science landscape. It's a concept I'm going to revisit throughout the book, since it allows us to diagram the relationship among all the new terms we're going to encounter. I find that learning lots of new and complicated terms can become intuitive if a reiterative two-step approach is taken. In the first step, I just want to be clear that we understand what the terms properly mean. In the second step, I want to help you build links between the different terms and understand how they're related to each other and how they influence each other. This is done by looking at various examples and getting you to perform the tasks on your own. As a learning aid, I'm going to be referring back to this diagram throughout the video course. I want you to think of this as our goal. Here we can see the big picture. It's where we're headed. I'll bring in individual terms piece by piece and draw the landscape as we go along. By the end, you'll have encountered all of these terms, and by that point, you should also know how they're connected with each other. To this end, we'll return to earlier material where appropriate and show how new terms fit into the landscape of deep learning that we've already built. It's easy to lose track, so I've made the landscape diagram available for download so that you can refer back to it throughout the video series. I'll also refer to this map for each of the case studies we'll encounter. You'll see how the parameters and components of the landscape change in each situation to account for different analytical problems. But that, in the end, the underlying framework is the same in each situation. We just take a different route to get to our destination. We're going to talk a lot about neural networks, which of course evokes an image of the brain, this large mass of neurons. You may see some popular science articles mention that neural networks try to mimic how the brain works, or that we're trying to create a simulation of the brain. That is incorrect and is far from true. We do want to invoke an image of a neuron, but the quality that we're referring to is the connection between neurons. Every neuron in the brain is connected to many other neurons, receiving both input and producing output to downstream neurons in signal transmission. Our representations are going to look like this and should give the impression of being activated over and over from input to output, just like neurons are. That's all. So don't fall into the hype trap that deep learning is trying to recreate how the brain works.